again in the workshop. Bit of an update, and then a bit of work, all in this video hopefully. I've had a lot of positive comments. I've had a lot of chats with different people about different things, and if you've been following the Facebook page, you notice I've been doing a lot of work, and that's going to kind of what's going to go into this tonight, into this video. So hopefully all goes to plan, but as you know, I wouldn't post it if it hadn't gone to plan or doesn't go to plan. So yeah, there we are. So a little update. What can I show you tonight? I'm waiting on some more parts. They're due any day, from Ed again, some laser cut buckles this time. So you remember, I don't know if it was last week or the week before, I showed you the buckle that went round the springs. I've sent off for some laser cut ones, the correct width that I need to go round the spring steel. The spring steel I've still got to order. I found the right thickness, I believe. So hopefully, all being well, I'll be able to just put a curve in it, bend it, cut them all, put a slight curve in it, and then start to offer it up, and see what the comparison is to a works drawing and everything. Talking of works drawings, I didn't realise I sent off some for the engine, for the pony truck centre, one or two other stretches and stuff like that. I didn't realise that they wait until they get loads of people to do an order, and then they ship them all off and have them all scanned all at the same time. But for some reason this time around they said for goodwill, you can, here's one of your drawings that you wanted, and they sent through the casting part for the pony truck. So that's allowed me then to start putting that part into the equation on the works, on my drawings that are copying the works drawings, obviously. The pony truck centre is on the Dick Stockings drawings, the actual stretcher itself is just kind of a big block of cast iron that the actual main pin drops through and sits on top of the pony truck. I didn't want to do that because, again, we're not doing what I set out to intend to do, which was put a lot of detail in. Not that you're going to see it, it's right up inside the frames, under the front of the smoke box. You're not really going to see it, but it's one of those things that you could, if you tried, get underneath and kind of you'd see it. So it's one of those things that I've decided to put in, just for that curious eye that goes and looks at it. So without waffling on too much, some of you may not seen on the Facebook page me putting in that part under there. Let me bounce the light off it. So I silver soldered that, I had that come through from Ed, and I silver soldered it up underneath here, and you'll see there's a water valve just basically placed in place. Now when I was doing this, when I was drawing it out, I didn't take into account the sizes of that water valve, commercial water valve. I don't know if you can just see it in there underneath. I'm bouncing the light off it a little bit. I didn't take into consideration that at all, and I didn't know if it was going to fit up underneath, and it does perfectly. And you can see that it does perfectly because there's the valve handle. Now our engine won't use this type of handle. It won't have a handle there and a handle here. It'll have two handles on one, and there's a linkage that goes behind them. So I've just basically put that in to show you that it comes through exactly where I wanted it to. You'll see as well the drag box is all nicely painted now. Keep that dreaded rust at bay. And I've started work on the drag beam. So these are the rubbing plates have been riveted on, but there's also, I don't know if you can see it, there's also a couple of 7BA slotless screws put through. So that's so I can pull that drag beam onto the drag box and tighten it all up. I've put in rivet detail on the face, which goes through to this angle in the back. Now the angle in the back, I had to do dome head or snap head both sides. And I was working out, and you remember I put on, you know, what should I be doing? Everyone goes 1.5 times the diameter. That's fine. I knew that anyway. But what I didn't know, because I'm not using 3/16 for the drag beam, I'm using 16th angle that sits behind it, but it's 4mm for the drag beam. So obviously there's a discrepancy there. So it wasn't a case of 3/16 plus a 16th, and then, which obviously gives you a quarter, and then 1.5 times the rivet was showing. I did a bit of a complicated around the houses type of calculation and came to that it was just fractionally shorter than 3/8, and I mean only fractionally. I had a comment on the page that says, oh, go to this website, they do all different rivets and that, and it shows you the squeezing allowances and stuff like that, which I found very useful, because the extra that was in that 3/8 rivet was the squeeze allowance. So I thought, I bit the bullet and thought, sod it, I'm going to go in and leave them at 3/8 long, 2 snaps together, one on top of the other, and I went for broke, and it worked out perfectly fine. All got a nice snap head on the back. Obviously the front's going to be right, because that's the head that's already formed. These two here, they're at the minute, they are 7BA slotless screws. That's what we're going to work on tonight, and I'm going to go through my riveting tool, because I didn't realise a lot of people are interested on its setup. Now I'd love to say that I designed it and made it myself, but I didn't. My late father did, and he was a self-taught engineer, and something that me and him used to love doing was bouncing ideas around with each other of how we would overcome something. So we knew when we was doing the frames on the previous class 2, we needed to hold these on and to rivet them up. Now the frame's quite long. We could have done it where I held the frames and he knocked the rivets in, but he liked to work on it when I wasn't there. So he came up with the design that I'm going to show you and explain to you tonight, which you've probably already seen in 1 or 2 pictures. But I'm going to give you a rough idea of the dimensions and the steel that he used to make that. It's basically a double snap holder. You know, you can put a snap in the bottom and a snap in the top, and you can hold frames because it's got outriggers that screw in. You can fit frames on it. So it's going to be this video, pre-warning, it's going to be a bit of a lengthy video because I'm going to explain that. So we're going to go off into the other side of the workshop. I'm going to set the tripod up. You won't see me in the picture or anything, but you'll see me explaining what's going on. But first of all, I need to part this drag beam back off the drag box, so that I can work on it, and then we'll go through into the other side, and we'll go from there. See you shortly. Okay, so here we are. Got the main parts of the riveting tool in the vise. So if I just show you this quickly, I'll just turn it on its side. Big main bar, you can see there's a couple of bolts into a plate there. Yeah, it's obviously turned that in the lathe. Yeah, to put this, so it's stepped down. This is a collar, the top piece. So this bar here, it's split there, Allen key through it, so it can be rotated or whatever to suit your application. Main back piece here is just a bit of bar, looks about 1 inch diameter. And then obviously the top piece, this top piece marries up with the length of that one for obvious reasons, because you want the top snap to be straight over your bottom snap. It is adjustable here. There's another split in the back there, and there's a split in the face here. So what he's also done, rivet snaps. Now that you can see, these are not like your commercial ones. because they've been turned down. So I can't remember. I think what he did is he bought commercial ones and left obviously the dimple for the head of the rivet, and then he's turned the rest down so that we can get nice and close. If you've got something where you need to get the snap right nice and close, this is turned down so that it allows that to happen, but not turned down too much that when you start bashing a rivet in, it squashes it and deforms it. So what he's made obviously as well, that obviously fits your snaps, and then the snap fits in there. That pushes down and it hits the bottom of this metal plate, and that's what you can hear, that noise as it drops in. That at that point then isn't going to move, because before, when we first started doing rivets on the class 2, we were pinching a snap in a vise and then hovering material over and trying to, it was a case of me and my dad all, you know, 4 hands on the go, and it was really quite difficult. So he's done a top collar, top bush that fits in there. This has got a grub screw in it. Okay, now the grub screw pinches against the side of the snap or blank that's at the top. So if I was doing countersunk rivets, I've got this one, so that you can see there it's dead flat. It's like a big punch. That'd fit in there. They're a tight fit for obvious reasons. Now, the reason they're a tight fit, obviously the weight of the hammer is going to whack it through anyway. But if there's loads of movement up here, when that rivet starts to get squeezed up, it'll try and bend over to one side because your upper snap's allowed to waggle about. So that's why that's got a pinch on it there. So I can nip that up and tighten that even more. It's a nice slide fit at the minute, and so are the upper snaps. So I want a 332 snap for the upper one. That's that one. And as I say, look, it's a tight fit, but I can get it through, and they sit above each other. So now when I come to doing what we're going to do on this next job, that it will stay dead in line where I need it to. If it tries to, if this isn't done up tight enough and starts to move to one side, I'll see it happen. I'll see it here first. So then you think, well, how do you do long material? Well, this is where this little jobby comes in. So this is the next bit that he made. It's very simple. Bit of 3/8 bar, I think that is, threaded on one end there. Let's put some light on it. Threaded there. Then it's a block, drilled that way and drilled that way, drilled that way and drilled through that way. That's allowing for this T-piece to slide up and down or turn or whatever. It allows it to travel the length of this rod. I've got 2 of these, and they screw into the end of here, like so. It's quite a coarse threads. I'm not sure what it is, but you can use whatever thread you want if you was going to make your own tool like this. Remember where you saw it first. We're not charging for any information on this. It's all a freebie to you model engineers. If it helps you do your particular work at home on your own, then it's worth its weight in gold. So I've nipped that up on there. If by chance that isn't flat, yeah, which I haven't got my spirit level in here, if that isn't flat, don't roll it back so it's loose a little bit, which you can do if you wanted to, but you want that to be, that rod to be tight. Undo one of your pinch bolts there, flatten it up, put a spirit level on it if you want to. Just level it up so that that's in level in here. And then you want to marry your height up. If I take that out of the equation, you want to marry your height up here as well. so that when the material, when the part is in, it's not up or down like that. You want it nice and flat. So where that is at the minute, I want to do these two here. So where that snap's going to be, these are in the way. So I need to shove this up this way a little bit to a nice flat part here, where it's not interfering with anything, and it's going to hold it dead flat like that. So that's where we're going next. Then I'm going to take one of these bolts out, yeah, push a rivet through, snap on top, whack it a couple of times with the hammer. There'll be a sound change as it happens, which I'll explain as I'm doing it. And yeah, jobs are good, and as they say. But that's how I got all these done in here, in the back of here. Yeah, putting that on there. When I do a countersink one, which you've got here, if you can see that, I put that blank punch in the top, put it on there, blank punch through the top, whack it a few times, fills the countersink up nicely. Awesome. Right, so bear with me, I'm just going to set all this up so we can do them couple in the back. So here we are, all set up. I've just got my baby spirit level out to make sure that that is level across there. No problem. I've got the right level here, allowing for that to sit on there. So that is that bit done. So what I need to do now is obviously remove one of these bolts in here. Now 7BAs in a clearance hole, or 332 clearance hole, they're a snug fit. I'm not even joking when I say they are a proper push fit through. So it's like if you ever watch a video of someone riveting up something on full size, they obviously bolt it in first, and the bolts are not a rattle fit, they are proper snug fit, because they want that part not to be moving about when they snap up, and they're going to be obviously doing hot. We're not doing hot because we're doing copper, and copper can form a lot easier. The only thing is with these, when you've got fingers like mine, you feel it's loose enough to turn with your fingers, but your fingers are that massive that you can't get in to undo it. The clearance in the back of here is very, very small. It's only 3/8 angle in this corner. 3/8 by 1/16. It's very small. It's not the smallest. You can do 1/4 by 1/16, but our works drawings required us to do 3" angle, and the nearest we can get to 3" angle calculated down, it would actually be bigger than 3/8, it'd be just a fraction over. But we're using 3/8 angle because it's the nearest equivalent in our size. Might have to edit this bit out, it's boring, isn't it? Watching me faff about with a bloody 7BA bolt. So before I take the nut off, I'm just going to try and push that back out, which it's not going. That's always good, isn't it? What do we do in that scenario? Try and use the spanner on top of it. Ooh. Didn't go in at all. So I'm just going to slacken that other bolt. She ain't going still. Right, I'm just going to bugger off into the other side and get that out. So bear with me a second. Right, it's out. As you can see, there's only one in it now. Let's remove this lot up here a second. Till it was a tight fit, it's cleaned that thread on that as it's gone through the hole or come back out through the hole. But they all come in handy for holding something at a later date, so don't ever chuck them away. Right, 3/8 copper rivets. Now I looked at it then because I noticed in one of my packets, I don't know if it's in there or in this little packet of this little tray of rivets in here, one of the rivets in a packet didn't have an actual correctly formed head. Now I know what you're thinking, I've got a snap there to do the job for me. I have, but if by chance there isn't enough material, the head won't be formed at all. So then I'll have a duff one on the face, which I don't want. There we are. So it's all held in place. I haven't got to mess about trying to balance anything or out like that. I get a fairly big hammer for this job because I want to kind of do it in as little taps as I can, as little number of taps as I can. I'm holding the part steady and I'm just going to whack the top of there. So if everything starts to shake, I do apologise now beforehand. Now the sound changed as I got to the bottom, as I went to finish it off, and it will stick in the snap a little bit, but that's it, job done. Snap head both sides, exactly what we want. And you'll even get, if you hit it further still, you'd get a ring around the outside of the snap head in the material that you're riveting up, which you've got to be careful of, because all you're going to do is deform the actual thing that you're riveting up, which you don't really want to be doing. You want to form the rivet head that it's squeezing the metal correctly, and it's all good. So we just take this one out. Oh, this is just as difficult as the other one was. So bear with me a second and I'll sort this out. Right, we're back again. Okay. You can see what I mean. It's a nice, the rivet just nicely drops in. Dead on 332. Now when I had this drag beam laser cut, I'm going to take that out for a sec because I need to get this in without it falling out. So that's why I keep holding on to it with my finger. Yeah, when I had this beam laser cut, 332 holes, I blasted straight into it. And now I know what you're thinking. Why would you laser cut a hole that's going to have a rivet in it? You know, it's going to deform, especially going through 4mm plate. The rule of thumb I was always told that if there's a hole smaller than the thickness of material, it won't cut it properly. That's what I was always told. This drag beam and my mainframes tell a different story, because they are 332 holes laser cut into 4mm plate, and all I've had to do is wipe the holes with a countersink. And I say when I say wipe it, that's the countersink, and I'd literally just do that, obviously the right way around, not backwards. Do it the right way around, give it a wipe. That takes any dross off that's in that hole, and that's it. Job done. So right, next one. What was that, 4 whacks with that hammer? If that's stuck. If it sticks like that, get me toffee hammer. It's because it's tried to move or what it's done, it's actually formed the head that good inside that snap. It's just grabbed it a little bit. There we go. Number 2. There. And that's why you can see why they've been turned down, so that I can get into a bit of 3/8 nice and close. Head both sides, no bother. You can get in nice and close. You can see the snaps right up against that, and that's on 3/8. Now I know that when I come to doing the cab, that's 1/4 by 16th. Well, I probably will do it thinner than that, than 16th angle in the corners of the cab frame working around the outside, because 1/4 by 16th brass angle at that smaller thick profile will look awful inside the cab. So my train of thought, I'm just trying to find you a bit of 1/4 to look at. So my train of thought at these early stages, in fact I haven't got any, I thought I had a bit. My train of thought in these early stages for the cab is to laser cut 2 profiles. One, the shape of the cab on the inside, and then a strip that I will silver solder to it. The downside to that is that it's quite a big thin piece of metal, and it will obviously try and distort. So I need to figure a way of kind of holding it together sufficiently for me to get the heat into it, to silver solder it and get the shape. Then obviously I've got to have the figure out how I'm going to hold it on here to put the rivets in, because they're dome head both sides. Lots to think about, but that's on the engine. I know I've got the tender cab, half cab to do, but I'll worry about that when I get there. So what I'm going to do, I'm just going to whack in these other 2 on this other side, on that end. I'm going to whack those 2 in quickly, and then we'll bugger off back in the other workshop, or the other part of the workshop, and talk through it. Happy days. Right, there we are. Rivets, lots and lots of rivets. Same on the back, there and there. Snap both sides. So, I hope you found that some sort of some informative or whatever. You notice I didn't go through sizes of that riveting tool. The reason for that is there's no right and wrong with the sizes of the base plate for the snap to sit in, what you pinch it in the vise with, the distance of that arm, you know, to give you the room to fit material under it. That's entirely up to you on your application. If you've got deep tender side plates with loads of rivets in, say on a Britannia or a 9F or something like that, or a Stania tender or whatever, and you've got a big plate that's got lots of rivets that you're gonna, you know, you want to put the rivet detail in, but they might be dummies or whatever, that depth on the back there might need to be greater than what I've got on mine. For mine, the BR standard, the BR3 tender doesn't have deep sides, so we didn't need a lot of distance to hold the top snap over. That suits our application. So that's what I mean when it comes to doing your own, making your own tool for that, it's entirely up to you what you do. That outrigger, that T-piece that holds the material level, when I come to do the frames, which I'll do a video on, when I come to doing the frames and putting the outriggers on and the angle and stuff like that, the other one will come into play, because there's 2. There's one either side that are threaded in the ends of that centre bar. that other one will come into play to hold the frames dead flat from one side to the other, and it'll all work pucker. So there we are. That's going to be quite a lengthy video, I think, for me anyway. I hope you find it informative. Thanks ever so much for asking the question. You know, on that's a nifty bit of kit, how was it done? Hopefully next time I speak to you there'll be some more progress on something. I'm firing along. This bit now is going to get a splattering of primer to keep the rust off it, because I've been handling it a lot, and I don't know if anyone's told you, but if you're handling steel plate and your hands are a little bit clammy, you could come to this the following day and find that there's little bubbles of rust starting. I've had that a few times, especially on a hot summer's day. Come out to the workshop, handle a bit of round bar, put it down, and it's not had any cutting fluid on it or out like that, and then I'll come back the next day and where I've handled it, it started to try and go rusty. So it's a bugbear of mine, that bloody rust, but there we go. We keep fighting on. Yeah, so thanks for watching, and yeah, we'll see you next time. Keep the questions coming. Cheerio.